Welcome everyone. Thank you for joining. So, as Eric said, welcome to our new shiny new office. This is our first home welcome meetup here at the office. And thank you most importantly to you all for joining us this evening. As Eric said, my name is Mike Metral. I'm an engineer here at Pulumi, focused on the Kubernetes portions of our toolchain. And to give you a little bit more context about me, I've had the good fortune of working with many organizations, small, medium, and large, to go into production with containers and Kubernetes throughout the past couple of years. And I actually got involved in Kubernetes like a week after the initial commit, so just on the like 4.5-year mark for like 5 years of experience in Kubernetes. So needless to say, I've been pouring my life into this project for the last couple of years, and I'm here at Pulumi, so that's something. With that, right, I've also seen the full gamut at how complex and just mind-boggling this space can actually be. Not just to use it, but to really get it ready for production. And in this talk, I essentially want to talk a little bit more about that problem space, give you a little bit more context and background on Pulumi in case you aren't aware of what we do, and then showcase how Pulumi can help you with your Kubernetes clusters and really aim at stop reinventing the same Kubernetes clusters, because we're all plagued by the same problems. So let's talk a little bit more about the problem space, right? In a former life, I worked at CoreOS, and we had our own Kubernetes installer, right? It's called Tectonic. And Tectonic was, it started off as a bunch of CloudFormation templates on AWS. As we had more demand for folks, for other like cloud providers, we grew that into something that was pretty much a Frankenstein of an installer. CloudFormation was very brittle for us. And at the same time, because we wanted to pivot to other clouds, we wanted to have a way of programmatically writing code once and applying to all different providers. So Terraform naturally lent itself pretty well for that. That being said, as the leader of the field engineering team at CoreOS, working literally hand in hand with all these companies, I quickly saw that there's not one installer to rule them all. There's many different distributions of Kubernetes. So CoreOS had their own with Tectonic, Red Hat has their own with OpenShift, there's a bunch of other small players in the mix, and now you even see the cloud providers in the public space have managed offerings. So we've definitely gotten a lot farther than we were 4 years ago, 4.5 years ago, but we're still not even close to being done if you actually want to use this stuff in production. So that's kind of one of the biggest pain points, right? Like no customer, no configuration, no cluster was the same because none of the requirements are the same. None of the designs of their applications or stacks are the same. So there's no way that we can create a single installer with a common foundation that's going to be able to like, leverage public, private, and on top of that, the amalgamation of configurations you can imagine both for the cluster and the apps running on top of it. So we hit our limits pretty quickly with Terraform at CoreOS because, as you all may be familiar, it's not a programming language. Like we had a manual internally from our team where like bullets 1, 2, and 3 where Terraform is not a programming language. And like we repeated that for steps 2 and 3 because it really was worth repeating. The amount of lack of logic, conditionals, usual kind of bells and whistles you get in a full programming language, ultimately what we always wanted out of Terraform, but we could never get there. That being said, Terraform opened a world of differences for us as far as being able to support many clouds, both public and on-prem, and it ultimately led us to getting acquired by Red Hat. But that kind of shows kind of the pain point of really what the state of the art is today, right? And so, because we wanted a programming language, we didn't really have those constructs, and it just so happened that I just happened to stumble upon Pulumi and kind of fit that bill. So, what is Pulumi, right? Pulumi is a collection of infrastructure as code libraries for your favorite languages that allows you to define, deploy, and manage your cloud-native infrastructure and your Kubernetes clusters and your applications on top, all through real code. And that is not to be taken lightly, right? Like you now have the full expression of a programming language in your favorite language of choice, but you also have all the extra add-ons that as a developer or an operator you're used to operating with regards to like IDE integration, type checking, linting, auto-completion, documentation, and even auto-completion of just the actual construction of these API types. And so we have an SDK for various clouds that are on a couple of different languages today. And it really is multi-language and multi-cloud. Not to mention, we have a platform that allows you to essentially run this out the gates with your distributed teams in a method that allows you to really have a delivery platform that protects against concurrent runs and also locks like importing state files that goes with the resource graph that we build out of your actual pieces. On top of that, we have the SDK, which is kind of a general kind of word for many different loosely defined packages. But at the very bottom, we have the ability to hook into many different providers, both public and private cloud. On top of that, you can control either containers directly on the kind of ECS platforms, right? You have serverless for Lambdas, and you can have core infrastructure like Kubernetes. And then on top of that, we try to have an abstraction where it makes sense that doesn't break the abstraction to the point where you can't be useful with the core resource if you actually need to, but it's helpful enough that it removes a lot of the pain points. And it really is about empowering you, your team, and ultimately your platform for how you want to actually operate across various source code tools, languages, tooling for your CI/CD, and even, again, environments from the providers. So let's get to the real stuff, Kubernetes. If you took a high-level kind of overarching view of what it is to actually run Kubernetes in production, this is more or less what it would look like, right? And if you're familiar with the OSI model, it's no different. So let's work from the bottom all the way up. If we just focus on public clouds for the sake of this conversation, right? You have your providers who actually are the ones giving you your infrastructure on layer 0. Layer 1, you have the core building blocks that you're all used to working with, VMs, block storage, keys, registries. And then you actually have the clusters of Kubernetes. So the beauty of that, right, is that with services like EKS, AKS, and even GKE, layers 0, 1, and 2 are given to you pretty much out of the box with the hard part, right, the control plane being administered for you without having to necessarily worry about it. That being said, you're left with a vanilla Kubernetes cluster, and that is practically unusable for anything remotely production grade. So, on one hand, great, this thing's not going to fall over, and now I have a neck to choke when it does, but I still have to employ all the work, refactor all of my services, and then on top of that, configure the clusters to my settings and tunings based on whatever those apps that will be running on top of it need. So you can quickly see how this gets out of hand, right, for any amalgamation of applications running in a single cluster, let alone across multiple clusters. On layer 3, right, if you look at each of these segmentations as not only a segmentation of responsibility, but also as a segmentation of work and time and effort that you have to actually perform, this is just the tip of the iceberg that actually goes into each layer. So on layer 3, right, the cluster services, these are the services that are core to the cluster. Logging, auth, policies for runtime and resource management, making sure that runtimes are locked down, making sure quotas and multi-tenancy qualities of service are actually being met. And then you also have things like the registries and service meshes that some of these providers are providing to you as a managed service. Or you can run in cluster. Once you get the cluster configured, now it's time to set up all the services that your applications depend on. Logging, monitoring, English controller for north-south traffic, right? Service meshes kind of bleeds in between both for east and west traffic. You have DNS managers, you have cert managers, right? And the list goes on and on. And these are just the shared services right now of the cluster and the applications. And then at the very top, layer 5, is your real work, where it's trying to port your existing stuff to work in this new world, where you actually need to properly handle sig term and sig kill and have to have rolling deployments and be able to have zero downtime. A lot of these things are taken for granted by folks, especially who are brand new to cloud native, and more importantly, brand new to Kubernetes. So how do we leverage Pulumi to help here? Well, in a couple different ways. So as I said earlier, we're a collection of different packages for various providers, various components of the infrastructure, and most importantly, for various languages. For layers 0, 1 through 2, we have essentially a package for each of the managed providers. On AWS, GCP, and Azure, those are the ones that are going to give you the core building blocks, right? The VMs, the storage, the VPC, the network, etc. But we also have other packages like for EKS and then an abstraction that lives on top of AWS to make it a little bit easier. So for the most part, we give you essentially libraries that are, again, extensions for your language of choice to configure each of these pieces. And so now we have complete control of our infrastructure in however expressive format that we want to actually use. If we move up the stack, we also have packages for Kubernetes natively itself. So this also exposed, just like in the previous packages, we exposed the VMs and the storage devices and the networking components. In Kubernetes, we also expose the same API resource types that you know and love from the API subsystem in Kubernetes. Also, we have a small preview experimental package that I'll be demoing in a little bit called the KX package, which is essentially, again, we have these core resource types in Kubernetes and in the native providers themselves, but sometimes that just requires so much boilerplate code that it'd just be nice if I could just have abstractions to simplify some of this stuff, either for ease of use, either for ease of development experience, or more for reducing the amount of working code I actually have. So, layer 5, we don't really have anything yet, but we are thinking always about how can we make the refactoring of your applications that much more fruitful so you can do it out of the gates. We have some theories, but we're not quite there yet, but we'd love to hear any feedback you guys have in that domain. So yeah, and at the end of the day right now, your apps are left to you. Ultimately, you know what goes in these apps. You know if they're pets or cows. You know if they need love or not. You know if we can eradicate certain portions of it, if it's ready for cloud-native zero downtime rollouts. Only you can answer those questions. We can certainly help, but at the end of the day, you own that stack. So, although we pawn this off on you, like I said earlier, we have some ideas as to how we can make this a little bit better that will hopefully drop in the future. So, that's all the material I have. Let's jump into a demo. So, in these varied stacks, right, if I just happen to pull this, this slide here, I'm going to essentially strip this down a bit and refactor it just for the sake of this demo. So, I've moved around AWS from the bottom to the top, but that's neither here nor there. Each of these colored sections, layers 0, 1, 2, and 3, are different segments that I will be demoing how you can leverage Pulumi to actually construct these portions for you, right? And we have packages for each of these. Now, mind you, this is just a tiny subset of what it would take to go from 0 to nothing in somewhat of a semi-production grade capacity. But nevertheless, at the very top, layer 3, I'm just running a deployment of an HTTP server with this load balance service and an ingress object. But I still need the ability to configure DNS, to configure load balancers for the ingress control that I have in the cluster. I have to have logging from both the cluster and the pods themselves feed into CloudWatch. And then I also need Cloud IAM creds because some of these services, like the DNS Manager and FluentD for CloudWatch, need proper creds with AWS, and Kube2IAM is a good source for that. So we also leverage in layer 1 the core AWS package we have to create AWS policies, policy documents, roles, and do the attachment of that. And then we move further up the stack into Kubernetes to provision the cluster, and then distribute actual workloads into those clusters. So far, so good? All right, silence is a good thing. So let's start with so each of these layers, I have 4 Pulumi programs, one for each layer. I'm going to start from the bottom all the way up. So step 0, we're going to actually provision a Pulumi cluster with EKS. So this is what it takes to actually, can we see in the back? No?
Keep going.
All right. Good. Better? Okay, cool. So there's more comments in this than code, which is always a good thing, but nevertheless follow along with me. So as you can clearly see, in here we have a couple of different packages. So let me look at what's in the actual repo itself. We have a couple of files. These YAML files are really just kind of ways for us in Pulumi to help you describe the configurations and the settings you have. And the other parts like tsconfig and the index and packaging is because we ultimately employ the runtime, in this case TypeScript through NPM, locally on the machine to actually use the packages and then deploy it to your provider of choice, whether that be a public cloud, whether that be Kubernetes, or both. So the first thing you're going to notice is I'm getting yelled at by my Vim editor saying, hey, I don't know what these packages are, right? I cannot find these modules. So this is already a great start to what we have with Pulumi just by using code, right? We don't have this in CloudFormation, we don't have this in Terraform, we don't have this in any other tools. So immediately I'm out the gates winning in the situation because I get to actually have usual tools at my disposal, but now for the infrastructure and Kubernetes itself. So how do we solve this? As I said earlier, we have TypeScript here and we use Node. So my package.json is nothing crazy, right? We import a couple of the packages that I alluded to earlier that I'm going to leverage here. I'll do an npm install. Does this thing, and hopefully my editor stops complaining. So immediately, right, like these are amazing pluses that we get just by using our packages. I could show you a default kind of out of the box and create everything from a VPC to an IAM role to this and that, but that's not realistic for what people actually use, right? Like people already have existing VPCs, they have existing IAM. All right, cool, thanks. And so here, that's on this one. So I have a pre-existing VPC. I just specify the VPC ID, the subnet IDs that I actually want to provision into. And then in my definition of my cluster, this EKS package, which we have in Pulumi, essentially abstracts the definition of how you're going to create your cluster. You set the minimum size of the worker nodes, the maximum size, the storage class. In this case, I don't apply the dashboard. And then I'm going to output some of these variables that I'm going to leverage in preceding stacks. So if you're following along the bottom of my tmux, I'm going to step through each of these different layers. And so the beauty of these outputs is I can leverage these outputs from Pulumi program to Pulumi program. So I'm going to literally pass them on along the line as I need them. In this case, I'm going to leverage the cluster role ARN and the instance role ARN that EKS requires for me to actually provision this service through EKS. So in Pulumi, if I do preview, I'm going to get basically a planned proposal of what's going to be created, what resources are going to be instantiated, and then how it's actually going to play out. If I do Pulumi up, which is how you do a Pulumi update, it'll actually go and execute that plan. But it tells you, do you want to perform this update? Yes or no, or details. In details, you get more of a rich diff of like what actually is being created here. So if I scroll up a bit, man, this text is huge. You see things like security groups, right? You see the actual cluster definition itself. You see some IAM, some policies, some roles, on and on, right? You guys get the idea. So,
is that output in the order in which it gets created?
Yes. So in the dependency map, right? Because everything essentially essentially depends on another object to some degree. We do that in the sense we create the map. So we create the tail object first, and then work our way up the map, right? And so this presents to you what's going to be created, not necessarily the graph itself, but the graph is actually exposed on our, if I exit here, if I'm in my dashboard, so this is my Pulumi panel, and on my cluster itself, which is Nebula here, I can actually see the resources both listed, and I can see like a resource graph of what all this looks like. Make sense?
Yes, thanks.
Cool. So, if I wanted to board this update, I'd do yes, but since EKS takes 15-20 minutes to provision, I don't want to bore you guys, and I've done the cooking show demo and switched over to one that is running. So, cool. Bomb. EKS is running. To show you that these are basically, they don't stomp over each other, I can issue another Pulumi update on my existing cluster, and it'll just yell at me saying, hey, there's nothing wrong here. Why are you even running this, right? Because nothing's changed in my spec for how I provision my cluster. I have 25 pieces in here. If nothing's changed, I have no work to do, and it exits, right? So, awesome. I have an EKS cluster stood up in 2 minutes. I beat their own time. So now that we've got the EKS cluster up, right, we now can move up this stack. So we've taken care of layer 0, now let's actually take care of layer 1. So again, the demo here is an HTTP server that's exposed through an English controller, and I have the ability to do external DNS with the DNS manager to configure the actual hosted record sets for that ingress. I have logging for both the pods in Kubernetes and the cluster itself. And then on top of that, I have the ability to do credential through kube to IAM, if you're familiar with kube to IAM. And that essentially allows me to annotate each of my pods, and then the kube to IAM basically interjects in the worker and allows the worker to assume the necessary role for that pod's necessity. So we've taken care of layer 0. Let's take up this care of the cluster services, which here is creating a couple of IAM policies, some roles, and then setting up Fluentd CloudWatch logging. So I'll move over to my next tmux tab. There we go. Okay, so this may be a little bit hard to read. Let me close this. So as I said earlier, right? You can have output go from stack to stack to stack. A stack in Pulumi is essentially just nothing different than an environment, right? Dev, staging, test, UA, prod, etc. So I have dev stacks across all 4 of these programs for each of these layers. This is the stack I just stood up in the previous one, right? So I can actually reference the previous stack based on a path that's local to Pulumi, and I can get that output from that stack and leverage it in this subsequent program, right? And so if I look at the output from the previous one, I can say pull stack output, if I can type, and it'll spit out things like here's your cluster name, here's your cluster role ARN, the same for your instance, and my kubeconfig. Don't worry, I'm not flashing any creds, there's nothing sensitive there because it's token-based. So, but these are the outputs that I chose to output, right? You can make this however you want. So I'm going to leverage the ARNs because I'm dealing with IAM right now. I'm going to attach a lot of these things to the existing profile groups that the EKS cluster stood up. So let me close this tab because that's all that really is. And in here, if I scroll down a bit, I have a couple of things, right? So remember, I got the kubeconfig as an output from my previous cluster. In Pulumi, we have this notion of a Kubernetes provider. We don't really know if it's a AKS Kubernetes cluster, if it's a GKE one, if it's an Amazon one. The reality is we kind of abstract over all Kubernetes. And so all we require to set up a provider in Pulumi is the kubeconfig, right? So if you use Kubernetes, that is all you need. So we specify the kubeconfig from the output we got in the previous stack, and then we will use that provider in each of the creation or definitions rather of all these different instantiation types. For example, we're going to create a new namespace with the namespace of my configuration using that provider. And you can hook that provider into all of your resources as you need to ultimately stand up these pieces. So what am I doing in this cluster services, right? I'm setting up a new namespace for my cluster services called cluster services. And then on top of that, I'm setting up all of my IAM. So if you've worked with AWS, all these IAM declarations should look very familiar to you. So I have a policy for kube to IAM. I have a role for my cluster that attaches to that policy so I can assume other roles on my workers. I have another policy for external DNS so we can configure Route 53 accordingly. Again, pretty standard stuff here as far as AWS goes. And as you can see, we don't really hide in this behind the scenes, right? We just give you the facility to describe these arguments as you need. We create a role for the external DNS, and then on top of that, we do the same thing for FluentD. FluentD has its own set of requirements to put logs into CloudWatch. We have a role for it. And lastly, we actually can deploy this using what actually behind the scenes here, I'm using the FluentD CloudWatch Helm chart. So I can use existing Helm charts if we want. I can use existing YAML. We have these constructs built into Pulumi to allow you to leverage these things so you don't have to refactor everything into Pulumi from the get-go. You can marginally go as you please. Pat?
Mike, it looks like you've done something interesting here as well that you glossed over.
What's that?
The IAM roles that you're creating, those are actually composed of multiple resources, right?
Correct.
There's abstraction over those?
Yes. So this is essentially, right, if I actually go into this, thanks for noticing, right? I ended up creating a class of my own to abstract a lot of this, right? So if you know you have a particular way how you want to deploy FluentD CloudWatch in this example, I have a class in TypeScript with the args that I need accordingly. I do some general checking just to make sure everything's employable. And then I even have another function that says, hey, I'm going to use the Helm chart here in this case. You don't have to use the Helm chart. It was just the easiest thing for me in the moment. And if I chase that one down, that one essentially is actually going in and standing up the Kubernetes Helm chart from the API itself, where all the Helm charts are stored. I can define extra variables. I can annotate it accordingly, like I do here. Remember, FluentD needs to be able to configure logs, so I annotate it with the pod annotation, thanks to kube to IAM. And on top of that, I can tweak it however I please, and always passing this provider saying, hey, use this Kubernetes cluster to deploy into. So that is essentially the gist of that. So let's actually run it. This one I will run because that's quick. So again, we're setting up IAM policies, roles, and on top of that, installing and running FluentD CloudWatch to aggregate both my cluster logs and any pod logs in CloudWatch. So this will complete pretty quickly. As you can see, you have natural updates given to you live, which, oh, then we're done. And it'll spit out all of the completion pieces as you need. So you don't have to believe me, let's just show you. If I So if I look at all of my IAM here, it'll go and actually provision all of these pieces for me. Here are the policies I created. Here's some more roles. And then I have the attachment of this. So this is my instance role where my cluster actually gets its permissions. That's stood up by EKS. We go in and attach that additionally with one more, right, with the cube to IAM. So all of this is done for me through code. So awesome. We now completed layer 1. So back to this one, right? So we've installed the cluster, layer 0. We've installed logging and policy for IAMs in layer 1. Now let's actually go install the application services that my apps will ultimately depend on. An English controller for north-south traffic, DNS manager for record sets, and then logging is already done for us in the previous step. Let's look what that code looks like. So if as I said earlier, you can pass reference to reference from each stack and pull out more output. Here I pull in even more output from not only the stack itself, but also from the stack cluster services that I just finished running. And I can then stack this up as much as I want and leverage this output to my heart's content. Let's close this one up. In here, because I'm essentially creating Nginx, here's Nginx, right? I have, just like I had a class for FluentD, I have a class that I created for Nginx that allows me to provide all the arguments as I need, right? If you've ever used Kubernetes, the reality is these installers don't work out of the box because there's no way we can literally contribute to all the settings you're going to want. And to even extrapolate that even further, something as fixed as Nginx is not used identically by any two orgs, let alone two companies. So you should ultimately be able to construct the pieces you want and swap those out with whatever configuration you need. Here is how I prescribed it, but by no means is this going to be the way that necessarily you use it, but the reality is you can do it however you want. So I created an Nginx English controller with a service type load balancer. I then do the same thing, I stand up cube to IAM as another daemon set across all fine workers, so that way they can all assume roles. And again, all of these are just simple, pretty straightforward pieces of, these are all the arguments, for example, that I want to configure the actual container runtime with. Here are the ports that I want to open it up for. And then lastly, I do the same thing with external DNS to manage my record sets. So let's actually run this. So if I look at my cluster, so because I have this output, right, of the kube config, I'm going to output my kube config. This is my previous cluster, so I'm going to show you this real quick. And then I can actually use kube control as I normally would. So right now, for some reason, my kube config is not working at the moment. I wanted to show you the.
What's the value of kube config, if you could?
That's it.
Yeah.
There we
So
go.
it's just
I have to actually declare I want the kube config out of my output. There we go. Okay, we're in business now. Cool. So the kube system is what comes out of the gates, and since we already ran the cluster services, there you see FluentD. So I'm going to run the application services, right? External DNS, the English controller, and ultimately kube to IAM. So let's do a Pulumi up on that program for the cluster services. Or sorry, I already did that one for the app services. Watch this in live as all these pods come up and down. So I have my application services namespace, which is populated right now with the English controller portions, external DNS, cube to IAM, and they'll all continue to create in the background. I think we should be done. Close. So again, the English controller exposes itself through a load balancer in Amazon. If you wanted to use the ALB English controller, you could certainly do that. In this case, I went the self-serve route, where I have the English controller with a load balancer provision for me that I will use as my single ingress for all of the applications that they will run. And I can actually see all this being not only created, but I get the output of that as well. So lastly, with all of these pieces now in place, now I can actually run my applications. And right, like you can imagine how lengthy this can be across a suite of packages for all these layers. So now let's focus on layer 3, the last and final one. So again, I use the output from the previous cluster, but I'll close that one for now. And in this application, this is just my demo. That's all it is. It is a namespace for it. It's a service that exposes it accordingly. If you've seen the Kubernetes spec, this is no different than what the usual YAML or JSON you're used to working with. And here's the actual deployment with the spec itself, how I'm going to expose this. And lastly, the ingress object that will be picked up by the ingress controller to provision it as far as host and path-based routing, and external DNS, which will go and set off the appropriate record sets for it on Route 53. And the beauty of it is that this is my entire application, start to finish. But this is all I actually care about from the app. All the other stuff are the requirements that my cluster and my applications need. So the breadth of it is pretty wide. Let's actually run this now. So this will fire off. I have a little window over here. So I'm currently running this lookup on a host for the ingress object. So I have meetup.apps.pulumi.tech is the actual host name that will be ultimately served by the Nginx English controller and then passed along down to actual deployment. So as this comes up, we're kind of waiting now for the load balancer to be provisioned. As this completes, just shortly, sorry the text is so huge you can't really see it. Will ultimately, so the ingress object is being created and then ultimately being fulfilled by the Nginx English controller and external DNS. So obviously this is kind of where the cloud providers really shine, right? You ultimately have to wait for these things to stand up, and even when, for example, on Amazon, when a load balancer comes up and you get a return, we all know it's not really live for like a year or two. So no different here, it's just facilitated for you in a couple of steps. So let's run this, always takes a little bit. Let's see what's happening in the background. Oh, there we go, okay, actually, it did exit, cool. So I actually output some useful curl commands for myself, but since I'm currently doing an NS lookup in the top right corner, I'm just gonna wait for that to actually return some valid record sets. And then we'll actually curl it. Let's see, make sure I didn't. Let's try. So if I look on Route 53, external DNS should have done its job. And this thing is huge. So after the application comes up, it always takes a minute or two. So, oh, there it goes. So external DNS actually set the record sets for me, and NS lookup should return successfully soon. Once it does, we can curl. Come on, DNS cache. Well, while that goes, and it succeeds, I'll do a curl command. But that is essentially kind of the gist of it, right? Like, you've seen how I've tackled each of these layers in their own separate programs, segmented by responsibility, and really kind of the focus of what it is they're aimed at doing. And I've done it all through code. So I have not walked into any sort of like templating format or some DSL or YAML and JSON that I don't want to deal with. And the logic and expressiveness that I have is really up to the author, right? So with that, here are all the links that you will need to get started if you aren't already using Kubernetes on Pulumi. The demo itself is the KX package. In that, we not only have the demo, oh, cool, this returns successfully, so this should work now. And I get foo bar, awesome. So I have a deployment running on top of Kubernetes configured the way I needed, and on EKS. And in this packages, right, so I'll flash that again. This KX package is still experimental. If you want the more solid grain stuff, our packages with regards to the providers are way more stable. But this KX library is essentially showcasing the various pieces I demoed here, right, which is the Nginx English controller, Cube to IAM, FluentD, external DNS. All these are kind of the vision we see as far as the building blocks going beyond Kubernetes, right? Some of these pieces can be rinsed, repeated, and included, right? If you can just import this in a line of code and configure it in one declaration, why are you messing with doing this all yourself, right? Your organization should be consolidating all of your code into actual reusable components, not kind of bastardizations of those. So with that, I will leave up the link slide just for the sake of you guys want to take pictures or want to actually make a note of it, and I open the floor up to questions.